Hello, this is Geometry, Lesson 4-7, Congruence in Overlapping Triangles. For exercises 1 through 6, separate and redraw the indicated triangles. Identify any common angles or sides. So this is 3 examples of an overlapping triangle. What we're going to do is separate them so that they don't overlap. Pause the video if you need more time to draw. On the left, we have triangle ABC. When I redraw triangle DCB, it looks like I have a side that is named the exact same thing, BC and BC. So that would be our common side or our common angle. So to answer the question, I'm going to say BC is congruent to BC. Notice my notation. Question number 2, triangle EFG and triangle HGF. If I redraw these, this is what my triangles would look like. We're looking for an overlapping piece, and again, it's a side. This side FG is here, and it is also on the other triangle. They're labeled the same, so the common side would be FG. Number 3, we first have to redraw and separate the triangles. So we're looking at angle L. It happens here and it happens here. Noticing that K intersects on LJ and M intersects on LM. So this green triangle is shaded down here, or is represented down there. So now in this one, the common angle is angle L. Angle L shows up here and it shows up there. Notice there's only one angle L, so I don't have to name it KLM and JLN. I can just name it angle L. Trying another example. Here, our overlap, we have a right triangle, so angle Y is right. And then the bottom triangle, angle X is right. So we're looking for a shared side or a shared angle. So I'm looking at this angle A. Angle BAY happens here, and angle XAB is that same angle. So again, we can call it angle A, or you could rename it with 3 vertices. Question 5, triangle GEH. Would go to there, and triangle FEH goes there. So sometimes when they're on top of each other, it's hard to see what piece is the same. It might help to redraw. For me, highlighting helps me see that EH is yellow and green. Down here with our vertices, this side is EH, this side is also EH. So sometimes it's helpful to redraw and sometimes it's not. So the overlapping side would be side EH. Number 6, MPN, MOQ. So this little piece OP is on both of those, but I'm having some trouble on that one, so I'm going to redraw them separately. So angle Q and angle N are not the same. Angle P and angle O are not the same. Looking at the top angle, this is NMP, and this one would be OMQ, so those two are also different. So looking at the sides, it looks like we're going to have to go with this little OP part. So N to P has a little point here, that would be O. And OQ has a point here, which would be P. So the part that we're saying is overlapping is this red piece and this red piece. Oh, excuse me. It would be this red piece from O to P, which is on the green triangle. And then on the blue triangle, it's from here to here. It doesn't give us a side of the triangle, but it gives us a portion of this bottom side. In the diagram at the right, angle A and angle C are congruent, side AB and side CE are congruent, and side DA is congruent to side FC. Which two triangles are congruent by side angle side? And remember that angle needs to be included. So if I try to highlight some triangles, I'm looking at angle A and angle C, looking at AB and CE, and then looking at DA and FC. So if I start highlighting, my picture begins to look like this. So those would be those three highlighted pieces, a little bit nicer than the picture I was drawing on. So then if we try to figure out what triangles can be formed with those three pieces, I'm noticing I have a lot of extra information. So then I'm going to cover some stuff up and maybe highlight that third side. So I highlighted that third side in purple. So doing that again. Can close off that triangle, and then in this last picture over here I can kind of delete the stuff that I don't need. So we're focusing on this triangle inside of here. So when we name those triangles, we're looking at triangle DAB. Triangle DAB being congruent to triangle FCE, making sure that the corresponding parts are in the same position. D and F correspond, B and E correspond, and so on. The other thing we should check is to see if that angle is included. So notice this blue angle is between the green and the red. So that works out. Let's take a look at a proof of overlapping triangles. It is given that angle ZXW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. So we have some color coding going on in our picture. The blue angles are the same and the red angles are the same. We're trying to prove that ZW is the same as YX. So to make this picture a little bit clearer, I like to redraw my triangles. And they're not perfectly drawn, but just so that you can kind of tell what's going on. The blue angle happens on sides ZW and WX, so that's why I have it notated here. And the blue angle on the right side is YXW, so YXW happens over there. And then the small red angle is on the left side of this triangle and on the right side of that triangle. So what I did was I slid the givens down. We're trying to make ZW and YX congruent. So we're looking for those two pieces. So I think what we need to do is prove those two triangles congruent, and then their corresponding parts would be congruent. So let's see what we can do. Do we see any overlapping parts? I notice that this is called WX and this is called WX. So in the original picture, WX is on both sides. So we can use reflexive property to define that that side is congruent to that side. So line 1 is an angle, line 2 is an angle, line 3 is a side. So we're checking to see if this is angle side angle, our side being included, and it looks like it is. So then step 4, By ASA, we can prove those two triangles congruent. Then, because those triangles are congruent, all of their corresponding parts would be congruent. So then we can get to our last step that says these two purple sides, ZW and YX, because of corresponding parts of congruent figures are congruent. Let's try a proof of another pair of overlapping triangles. Given triangle ACD is congruent to triangle BCD. We're trying to prove that CE and ED are congruent. So again, let's redraw it just to see if that helps us. Looking for any overlapping parts. And I notice that CD is congruent to CD. So in our proof, we have given, and then we can also say that CD is congruent to CD. So I'm going to add that in my proof. So I'm going to sneak that in after step number 1. I already have my proof written out, so I'm going to call that step 1.5. And I'm going to say by reflexive, CD is congruent to itself. I don't think I'm going to need that step, but let's just get it off our hands. We already know these two triangles are congruent, so any corresponding parts are congruent. So CPCF can give us a lot of different information. We want to figure out what is going to be the most helpful. So what I wrote down is ADC, which is this small angle, and BCD, which is this small angle down here. So in the separated triangles, you can kind of see it maybe a little better here and here. Then what happens is I have this little triangle down here. And in a previous lesson, we knew isosceles means that the base angles are the same. So because those base angles are the same, definition of isosceles triangle says that that triangle is isosceles. And again, what we're trying to do is we're trying to get this side and this side congruent. So this green triangle, if it's isosceles, then we can use the base angles theorem, or the converse of the isosceles triangle theorem. So if those angles are congruent, then these sides would have to be the same. So I would say that's more of a medium level proof as far as rigor goes. Last slide. In each diagram, the given triangles are congruent. Identify their common side or angle. Pause the video, try these questions. When you're ready to see the answer, push play. In question number 7, the shared side would be DC. In question number 8, I highlighted the triangles. Looks like angle K is the shared angle. Question number 9, UV. And question number 12, angle Y. This concludes my video.
When you find you got the music, got the music in you. Find you got the music, got the music